Did you ever wonder how artificial intelligence could revolutionize the way we understand the very building blocks of life? Imagine a tool so powerful that it can predict the intricate structures and interactions of proteins, DNA, and RNA with unparalleled accuracy. Today, we delve into the world of AlphaFold 3, the latest AI model developed by Google DeepMind and Isomorphic Labs, poised to accelerate the development of new drugs and treatments. Let's explore how this groundbreaking technology is unraveling the complexities of life's building blocks. AlphaFold 3 represents a significant leap forward in AI-driven molecular biology. Building upon the success of its predecessor, AlphaFold 2, which made significant strides in protein structure prediction, AlphaFold 3 expands its capabilities to encompass a wide array of biomolecules, including DNA, RNA, and ligands. But what exactly are ligands, and why are they important? A ligand is an ion or neutral molecule that binds to a central metal atom to form a coordination complex. By accurately predicting the interactions between these molecules, AlphaFold 3 provides an unprecedented view into the complex workings of life at the molecular level. At the heart of AlphaFold 3 lies an improved version of the EvoFormer module, a deep learning architecture that was key to AlphaFold 2's remarkable performance. The new model also incorporates a diffusion network, similar to those used in AI image generators, which iteratively refines the predicted molecular structures from a cloud of atoms to a highly accurate final configuration. This evolution makes AlphaFold 3 a more powerful tool for exploring the molecular foundations of life and aiding in drug discovery. One of the most promising applications of AlphaFold 3 lies in its potential to revolutionize drug discovery. By accurately predicting the interactions between proteins and drug-like molecules, such as ligands and antibodies, AlphaFold 3 could significantly accelerate the development of new and more effective therapies. Traditionally, the process of drug discovery has been time-consuming and costly, often relying on trial-and-error approaches to identify compounds that can effectively target disease-related proteins. In conclusion, AlphaFold 3 represents a major milestone in AI-powered molecular discovery, with far-reaching implications for medicine, agriculture, and environmental science. As researchers continue to push the boundaries of what's possible with these tools, we can expect groundbreaking discoveries and transformative applications in the years to come. AlphaFold 3 is not just a tool, it's a glimpse into the future of molecular biology, where artificial intelligence and human ingenuity converge to unlock the secrets of life itself.